Now today we'll discuss briefly on binomial distribution. Okay, all of you know when we'll apply binomial distribution, what is the binomial distribution? Just I will give brief introduction of this one, binomial distribution. Okay, binomial distribution is a discrete probability distribution. It follows Bernoulli trial. Bernoulli trial means an experiment contains only two possible outcomes, success and failure. Success and failure. The type of experiment is called Bernoulli trial. Okay. Now all of you see conditions for binomial distribution. Binomial distribution will be applied under the following experimental conditions. Okay, all of you see the first one. Yeah, see the first one. The number of trials n is finite. The number of trials n is finite. Okay. And the second one, the number of trials are independent of each other. The number of trials are independent of each other. And the third one is the probability of success. P is a constant. The probability of success P is a constant for each trial. For each trial. Okay. And see the fourth one. Each trial results in two mutually exclusive events known as success and failure. That means the experiment is a Bernoulli trial. Bernoulli trial means the experiment contains only two possible outcomes, success and failure. Success and failure. In these cases, it can apply the binomial distribution. Okay. Yeah, P is the probability of success. Okay. And probability of failure is denoted by Q. Probability of failure is denoted by Q. And see the definition. A random variable x is said to follow the binomial distribution if it assumes only non-negative values and its probability mass function is given by probability of capital X. Capital X is a random variable. Small x is the value. Okay. Probability of capital X equals to small x, that is equals to f of x, which is equals to ncx into p power x into q power n minus x. N minus x. And here x indicates the number of success and small p indicates the probability of success and small q indicates probability of failure. Probability of failure. And n indicates the number of trials. Okay. And remember here x is only for non-negative values. That's why here x is taking values 0, 1, 2, so on, n. 0, 1, 2, so on, n. This is about the binomial distribution. Okay. And total probability is 1. Already we know that. See, that is the notation for this one. Summation x equals to 0 to n ncx p power x into q power n minus x, that is equals to p plus q or q plus p whole power n. That value is always 1. This means the total probability is 1. Okay. And see here, one problem we'll discuss now. All of you see that problem. Assume that this is the problem. Yeah, once all of you read this one, assume that 50% of all engineering students are good in mathematics. Okay, determine probability that among 18 engineering students, exactly 10, at least 10, at most 8, at least 2, and at most 9 are good in mathematics. Okay, once all of you read once again this question, assume that 50% of all engineering students are good in mathematics. Yeah, determine the probability that among 18 students are selected, in that exactly 10, at least 10, at most 8, at least 2, and at most 9 are good in mathematics. Okay, there is a question. Now, the slides are visible or not? Anyone respond in chat box? Yes, I shared PPTs. The slides are visible or not? Yes, anyone respond in chat box? Yeah, okay. Now, I think all of you understood that question. Yes, all of you understood that question. See, once again, all of you read that question. I will ask questions. Yes, all of you go through that question because today is also a practice session. Now, Bhavana, tell me what is the n in this problem? Bhavana, 6J. Yeah, 18, exactly. 70, very good. Yeah, very good. Small n is 18. And what is that 50%? Here, the random variable x is the number of students good in mathematics. Okay. What is the small p? Assume that all of you see that question. Assume that 50% of all engineering students are good in mathematics. That means small p is equals to 1 by 50%. That means 1 by 2. If you know small p, you can get small q. Small q is, we know that p plus q is 1. From that, we can get q. Q is 1 minus p. Q is 1 minus p. Okay, I think all of you understood this question. Now we'll see the solution. All of you see that solution. Let capital X with a random variable denoting the number of engineering students who are good in mathematics. Okay, small p is the probability of students good in mathematics. That is 50%. 50% means 50 by 100. That value is 1 by 2. That value is 1 by 2. And small q you can get. Small q is 1 by 2. We know that p plus q is 1. From that equation, you can get small q. That is also 1 by 2. And n is 18. Okay, we are selecting 18 students. All of you see the question. See, determine the probability that among 18, that means small n is equals to 18. 18. Now the first question is probability of exactly 10 students are good in mathematics. Exactly 10 students are good in mathematics. For that one, the notation is probability of x equals to 10. X is equals to 10. Okay, we know binomial distribution. That is ncx into p power x into q power x. We know all these values and substitute in this one. N is 18, x is 10, okay, and p is 1 by 2, x is 10, small x, into 1 by 2 into n minus x, n value is 18 and x value is 10. Now all of you simplify, you can get the value, the required probability. Okay, I think all of you understood up to this point. If you have any doubts, once again I will explain that one. Once all of you read that question carefully, you can understand. Yeah, I think all of you understood that problem up to this point. Question and the first point, first question, first bit, right? Yeah, 71 show the conditions of the question. Okay. Yeah, 570. This is okay. Shall I move? Okay. First one. First bit is exactly 10. Second bit is at least 10. Third one is at most 8. And fourth one is at least 2 and at most 9 are good in mathematics. Okay, fine. Shall I continue with solution? 57D. Okay. I think first bit is clear. First bit exactly 10. That's why I taken here x equals to 10. Okay, what is the second one? All of you see the question. At least 10. At least means minimum. At most means maximum. Okay. See, all of you second bit. At least 10. That means probability of x is taking greater than or equal to 10. But what is the maximum? N equals to 18. For finding this probability, the notation is summation x equals to 10 to maximum n. Okay, n is 18. That is equal that into ncx into p power x into q power n minus x. Now we have to expand this summation and substitute all these values. All these values. Okay, expand this one when x equals to 10. Okay, I think all of you understood this point. All of you know how to expand and how to calculate the values. Previously only one is there, that's why we didn't use that summation notation. But here x is taking values 10 to 18. First case is this can be written as when x equals to 10, that is equals to 18 c10 1 by 2 whole power 10 into 1 by 2 whole power 18 minus 10 plus 18c11 into 1 by 2 whole power 11 into 1 by 2 whole power n minus 11, like that. Where to expand. I think all of you understood this point. Yes, got it? Okay, all of you find out that value, you can get the required probability. Yeah, second bit is also clear. Shall I move to next one? Yeah, let us see third bit. Third bit is probability of at most 8. At most means maximum. See, at most 8. Probability of x greater than less than or equals to 8. Maximum x can take value 8. What is the minimum? 0. Okay. For finding this probability, you can use this formula. Okay. Summation x equals to 0 to maximum value. Maximum value is 8 into ncx. N value is 18. Cx into p power x into q power n minus x. And p value is 1 by 2. Q value is also 1 by 2. N value is 18. Now same logic. We have to expand the summation and substitute the values. Then simplify. You can get the required probability. The required probability. Okay. Same thing, just now explained how to expand this one. First, x equals to 0. X equals to 0 means nc0. N is 18. 18c0 into p power x. X value is 0 into q power n minus x plus when x equals to 1. And 18c1 into p power 1 into q power n minus 1 plus 18c2 into p power 2 into q power n minus 2 and so on up to what is the maximum. The last term is 18c8. X can take value maximum 8. That is the last term is 18c8 into 1 by 2 whole power 8 into 1 by 2 whole power 18 minus 8. All of you simplify that one, you can get the values. This topic is already covered. This is the only revision and practice session. Okay, that's why I didn't wrote clearly this one. I think all of you following. Yes. Similarly, all of you see the second last bit. The question is, see at least 2 and at most 9. For that, the notation is probability of 2 less than or equals to x less than or equals to 9. You can find this probability by using this one. Summation x is taking values, minimum starting is 2 and maximum is 9. Summation x equals to 2 to 9, 18cx into p power x into q power n minus x. Okay, expand the summation and substitute and simplify the values. You can get the required probability. The required probability. Yeah, I think all of you understood that concept in binomial distribution. First, all of you read that question carefully and decide what is the n, what is the p, and what is the x, and what they're asking. Okay. Anybody have doubt in this one? In this question? Okay. And also remember 2 points. What is the binomial mean of binomial distribution? Mean of binomial distribution, NP. NP. What is the variance of binomial distribution? Anyone respond in chat box? Mean of binomial distribution is NP. And variance is NPQ. Very good. Variance is NPQ. Here some more problems are there, but first I want to share today's assignment questions. After that, we'll continue. I think up to this is clear. What is the binomial distribution? Conditions for binomial distribution, when we have to apply, and this problem. Okay. Now I'm going to share today's assignment questions. Yeah, all of you know done. First assignment question. Assignment question 1. It has been claimed that in 60% of all solar heat installations, the utility bill is reduced by at least one third. The writing is not clear. There is somebody shared. Okay. Yeah, all of you note on that questions. Today's assignment questions. So the question is, it has been claimed that in 60% of all solar heat installations, the utility bill is reduced by at least one third. Accordingly, what are the probabilities that the utility bill will be reduced by at least one third in 4 of 5 installations? And the second one is at least 4 of 5 installations. Once read that question 1 carefully. Now I'll ask 2 questions. I'll ask any one. Now all of you read that question carefully. Once all of you go through that question carefully, I think all of you understood that one. Now I will ask 56G. Tell me what is the N in this problem. 56G. 56G. Are you there? Remember 56G. What is the N in this problem? 56G. Are you there? Okay, I will put absent for 56G. Next, I will ask randomly one student. Yeah, are you there? Very good. Now tell me, what is the N in first question? Already I explained one problem. Once go through this question. Now tell me what is the N. Okay, next 57N. 57N. Are you there? Now tell me what is the N. I'm asking N only. What is the N value? 5, exactly. Very good. Very good. 5N. Sorry, 7N. Raji, once again. Good. Next, I will ask 6e, 56e. Tell me what is the p-value? What is the p? Small p. 56e. Are you there? 56e. Are you there? In this one, small p is 60%. 60%. That means 60 by 100. We know n and small p. You can get q value. You can get q value. Okay, we have only few minutes is there. I'll give hint for that one. Okay. I think n is 5. All of you understood. Small p is 60%. That means 60 by 100. That means 0.6. 0.6. From that, you can get small q value. Small q is 1 minus p. 1 minus 0.6. That is 0.4. Now, once all of you see that first question, probability of 4 of 5 installations. That means in this question, first we have to find out probability of x equals to 4. The first bit notation is probability of x equals to 4. Okay, we know n, p, and q. Small x is also, we know that in first bit, that is 4. All of you know the formula, how to find that one. Okay, see the second bit, at least 4 of 5. This probability you can find in two ways. Okay, for this one, the notation is probability of x is less than or equals to, at least 4, no, sorry. At least means minimum. Probability of x less, greater than or equals to 4. Greater than or equals to 4, at least minimum 4. No. 4 also you can take. At least, see, at least 4 means the probability of 5, 7, D and 72. See the second bit notation, that is probability of x greater than or equals to 4. That can be written as probability of x equals to 4 plus probability of x equals to 5. X is taking two values. Right? All of you understood? At least means minimum. Minimum is 4. What is the maximum? 5. X can take value 4 and 5. Probability of x equals to 4 plus probability of x equals to 5. We know that how to find that probabilities. Okay, I think all of you understood that first question. And today, these are the assignment questions. 4 questions are there. I will share to CR. CR will share in respective group. All of you practice that problems. Okay, all of you practice that problems. And 5 o'clock, we'll conduct the quiz on same topic on binomial distribution only. 5 questions are there in quiz. All of you write the quiz exactly 5 o'clock. 5 to 5:20, the quiz will open in KMIT online classes. 5:20, they will close the quiz. Okay, I think all of you understood. Exactly 5 o'clock, all of you log in with KMIT online and write the test quiz. They will only get attendance. I think all of you know the procedure. Who will write the quiz? They will only get the attendance. Okay, now I'm concluding that session. If you have any doubts, I will clarify now. Yeah, shall I close the session? Because it's time to write the quiz. Only few minutes are there. Yeah, okay. No need to worry about this paper. These questions I will share to CR. CR will share to your respective group. all of you practice that problems. And today quiz is on only on topic the binomial distribution. Okay, thank you everyone.